Imagine spending hundreds of millions of dollars to launch a satellite into orbit, only for it to be destroyed by a paint chip, moving at 28,000 kilometers per hour. This isn't science fiction, it's happening right now. Earth's orbit has quietly become a cosmic junkyard, and the bill for our negligence is growing every day. From defunct satellites to shattered rocket parts, there are now over 130 million pieces of debris threatening every launch, every mission, and every dream of space exploration. And here's the kicker. Some of that junk has been up there for decades, traveling at speeds fast enough to pierce metal like paper. Today, we're diving deep into the economics of cleaning up this mess. Because if we don't, space as we know it may become unusable forever. The European Space Agency estimates that more than 36,000 large pieces of debris, bigger than 10 centimeters, and over 130 million smaller fragments are currently orbiting Earth. These range from entire dead satellites to nuts, bolts, and even flecks of paint. At orbital speeds, even a piece the size of a marble can destroy a spacecraft. One of the biggest threats we face is something called Kessler syndrome, a terrifying cascade effect where one collision creates more debris, which then collides with other objects, creating even more debris. This chain reaction could eventually make low Earth orbit completely unusable for decades. And this isn't just theory, there have been several close calls. In 2009, a defunct Russian satellite collided with an active Iridium communications satellite, generating more than 1,000 pieces of trackable debris instantly. And just in 2021, the International Space Station had to perform emergency maneuvers to dodge debris from an old Soviet rocket test. When satellites are damaged or destroyed, the costs are staggering. We're talking billions of dollars in direct replacement costs, lost communication services, disrupted navigation systems, and even lost weather forecasting capabilities. The ripple effects can be massive. Imagine GPS outages delaying shipping routes or disrupted internet satellites affecting global banking transactions. Insurance companies have taken note too, with premiums for satellite operators climbing steeply as the orbital environment becomes riskier. But here's the problem. Who pays? Space is governed by international treaties, and liability for debris cleanup is murky. Many pieces of junk belong to countries or companies that no longer even exist. And unlike garbage on Earth, there's no global sanitation service in orbit. If we do nothing, the opportunity cost could be catastrophic. A congested orbit could mean fewer launches, slower innovation in communications and climate monitoring, and reduced access to space for emerging nations. In the most extreme case, Kessler syndrome could lock us out of low Earth orbit entirely, delaying crewed missions, lunar projects, and even Mars exploration by decades. The good news? We're not totally powerless. Space agencies and private companies are experimenting with some remarkable solutions. Active debris removal, or ADR, includes technology like massive nets that ensnare debris, harpoons that spear old, satellites, robotic arms capable of grappling defunct spacecraft, and even lasers on Earth that can subtly change a piece of junk's orbit so it burns up in the atmosphere. Orbital tugs, specialized spacecraft that latch onto old satellites and push them into controlled re-entry, are also in development. Some companies now equip satellites with de-orbiting kits, allowing them to burn up safely after their mission ends. Policy is slowly catching up too. The US, European Union, and Japan have all introduced rules requiring satellite operators to remove their spacecraft from orbit within a set time after deactivation, usually 5 years, though experts say even that may be too long. But here's where economics comes in. Debris removal is expensive, and no single nation or company wants to foot the bill when everyone benefits from a clean orbit. This is the classic free rider problem in economics. Possible solutions include creating a global orbital sanitation market where companies are paid to remove debris, similar to how waste management works on Earth. Another idea is to introduce an orbital credit system, much like carbon credits, where operators are rewarded for removing debris or penalized for leaving it behind. Public-private partnerships could also play a huge role. with governments funding early cleanup missions to prove the technology, and private companies scaling operations for profit. There's even talk of turning space debris into a resource. Some proposals suggest capturing and recycling old satellites for their valuable metals, potentially creating an entirely new orbital mining industry. Imagine a future where cleaning space actually makes money. But we are at a crossroads. The next 5 to 10 years will determine whether space remains a thriving environment for innovation or becomes a dangerously cluttered dead zone. Cleanup is just part of the equation. We also need sustainable design practices, regulations with real enforcement power, and international cooperation to make sure we're not just slowing the problem, but preventing it altogether. In the end, the economics of space debris cleanup isn't just about protecting satellites. It's about safeguarding humanity's access to the cosmos. Because if we lose low Earth orbit, we lose a lot more than communication and navigation. We lose our ability to explore, to expand, and to dream beyond our own planet. If you enjoyed this deep dive into the economics and science of space debris cleanup, make sure to subscribe and press the notification bell so you never miss a video that explores the biggest questions shaping our future.